Hello guys, we will continue talking about pharmacokinetics as one of the main branches of pharmacology. As we stated before, pharmacokinetics studies the body effect on the drug and how drug moves through different body compartments through four processes of absorption, distribution, metabolism, and elimination. In the previous video, we talked about absorption and distribution, and in this one, we will continue talking about metabolism and excretion. This is Pharmacology Horizons. Let's begin. So when you talk about metabolism, you must ask yourself three questions: why, where, and how it's done. First of all, metabolism is a chemical transformation of drugs catalyzed by enzymes. Then the answer to the first question came: why do body need metabolism? Body needs metabolism to convert lipophilic molecules into more hydrophilic ones so it can be excreted easily. These polar excretable products may be inactive or active. Body has nothing to do to control the activity of the metabolites. Some drugs are given inactive and converted by metabolism into active drugs, and such drugs are called prodrugs. For example, we have drug like aspirin. It's inactive. When it's administered and subjected to metabolism, it's converted to salicylic acid, which is the active metabolite or the active form of aspirin. Levodopa has the active metabolite of dopamine, heroin, morphine, codeine, morphine, and so on. So, to the second question, where does metabolism happen? Metabolism majorly happens in the liver, however it can also occur in other tissues according to the presence of the enzymes. So many chemicals may be metabolized in the kidney, lung, or even on the surface of the small intestine. The third question is, how is that done? Metabolism occurs through a series of reactions. When the chemical reaches the liver, we can classify these reactions into phase 1 reaction and phase 2 reactions. Phase 1 is also called functionalization process. It means that it deals with a functional group in the molecule and not the whole molecule. Example to phase 1 reaction are hydrolysis, oxidation, and reduction. Phase 1 reactions are catalyzed by cytochrome B450, and we will have a talk about these enzymes in another video. So after the drug is exposed to phase 1 reactions, the produced molecule is called a metabolite. This metabolite can either be active or inactive. As we said before, body does not have any control about the activity. If this metabolite is polar enough, it's going to be excreted outside the body. However, if it is still lipophilic, it will be reabsorbed again in the kidney and circulates back where it's exposed to phase 2 reactions. Phase 2 reactions involves conjugation of this metabolite with some endogenous substrates like glucuronic acid, acetic acid, amino acids, and sulfuric acid. These reactions are mostly catalyzed by transferases for every substrate. So, for example, conjugation with glucuronic acid is catalyzed by glucuronyl transferase, acetic acid, acetyl transferase, sulfuric acid, sulfhydryl transferase, and so on. Another thing about metabolism that it can be done on many levels. So the drug may enter phase 1, then phase 2, then come back to phase 1, then phase 2, and so on. However, the produced metabolite in phase 2 is mostly inactive and mostly polar to be excreted, in most cases, not all the cases, and excreted through the urine. Another thing about metabolism is that it can be either induced or inhibited by some drugs. So we are going to have a talk about inducers and inhibitors. Enzyme inducers like phenobarbital, rifampin, and carbamazepine induce synthesis of cytochrome B450 enzymes or CYP450 enzymes. So metabolism of any drug taken concomitantly with these drugs will be faster than usual, and this will lead to loss of any pharmacological activities faster. Enzyme inhibitors like omeprazole, erythromycin, ketoconazole, cimetidine, ritonavir, and grapefruit, and so on, which is done through competition on the active sites of enzyme. Metabolism of any drug taken with these drugs will be slower than normal, and this leads to accumulation of this drug in the blood and increased activity of this drug, and it may reach toxicity. So what if the affected drug is a prodrug? You can answer these questions in the comments below. In most cases, or in the mentioned examples, we talked about the normal drug, which is given actively. So when you induce the metabolism of an active drug, it will be metabolized faster and it will be removed from the circulation faster. But how about if this drug is a brute drug? Then I think the activation of this drug will be faster, so it will have a more rapid onset. And the opposite is right for the enzyme inhibitors. The last process of pharmacokinetics is excretion. As you see, this is a nephron. Excretion through the kidney passes by three main phases: glomerular filtration, where the free drug is filtered through Bowman capsule, only the free drug. However, bound drug is not filtered, so it will circulate back to the blood. Glomerular filtration is affected by blood flow, so healthy kidney will have more drug going through them, will be affected by binding of drug to plasma protein and the molecular weight of the drug. Some drugs are not filtered, however, they are pushed actively towards the proximal convoluted tubule. This is the proximal convoluted tubule. Pushed towards the proximal convoluted tubule through a carrier, but this process is subjected to competition. For example, when penicillin and probenecid are taken together, they usually compete at this site. When they are taken together, probenecid passes towards the tubules or the tubules of the nephron. However, penicillin will circulate back to the blood. This was a traditional way to increase the lifetime of penicillin in the blood in the past. This is a process of active secretion. After that, a process of distal tubular reabsorption may occur. So non-ionized drug particles are reabsorbed again to the blood, while ionized drugs are trapped within the tubules and excreted in the urine. This process can be manipulated to increase excretion of some drugs. For example, aspirin as a weak acid can be excreted faster from the body when the urine is alkaline, and this can be done by sodium bicarbonate. Weak bases also like amphetamine can be also excreted faster than normal when the urine is acidified by ammonium chloride. This rule of ionization you studied before, as in the first case, aspirin as a weak acid becomes ionized in the basic urine, so it's trapped. This is a process of ion trapping, and it cannot pass tubular membrane. The same concept goes with amphetamine. We will continue to give introduction about pharmacology. Tell me in the comments what you think about this content and what type of drugs you need to know about. Don't forget to subscribe, like, and share videos. Stay positive, share your knowledge, and make the best benefit of your existence. See you guys next video. Bye.